I've had a lot of questions about how to calculate the resistance in a simple circuit. And so what I've done is put together one here with a 9-volt battery and a resistor and an LED, and I've got a little voltmeter going here as well. So what I've done is I've hooked up the resistor to the positive leg. It could go to the negative lead of the LED, doesn't make any difference. And so from the positive side of the LED, we're coming down to the plus side of the battery. And from the negative side of the LED, we're coming down to the negative side of the battery. And so I've got a little button up here where I can start a simulation. Watch the LED, it's kind of cute. That lights up as well as the voltmeter. So if I click on that, we'll see that we've got almost 9 volts in the battery, which is pretty common. Actually, that's a darn good battery. They're usually even less than that. But let's say we've got almost 9 volts here, and we've got a nicely lit LED, and we've got some resistor here in series with the LED. Let's see what the value of that resistor is. If I click on that, it comes up and it tells me the resistance of that LED is 365 ohms. So how did I calculate what size resistor I needed here to light up the LED to allow enough current to light it up, but to block current so that too much current doesn't go through and blow it up? Well, to make it a little bit more fun to go through this, let's put a power supply here instead of a 9-volt battery, and then we can vary some other numbers. So let me make that quick switch. Okay, I have switched out the 9-volt battery for a power supply. And now if I start the simulation, we can see we've got 9 volts and 19 milliamps. And we can see that up here. I can adjust the voltage either by retyping this or by rotating a little dial. So these things are kind of cute. Okay, so back to how did I calculate that resistor should be 365 ohms? Well, we've got Ohm's law to thank for that. Let me get up an Ohm's law chart here. Hopefully you know what Ohm's law is, at least you've heard of it, and know that it's what electronics people use to calculate stuff like voltage and resistance and current. Probably one of the most current questions I got was, what size resistor do I need to light up an LED if I've got a 9-volt battery? So I'm going to use that question as our little project here. But you have to do a little research. First of all, you have to research that LED. You have to know the specs of an LED before you can do any more work here. So I'm just going to let you cheat on that, and I'm going to tell you that a standard red LED takes about 1.7 or 2 volts. Current typically is 20 milliamps. I'm just going to use 20 milliamps because it's easy to calculate. And I'm going to use, let's say, a 2-volt drop across that thing, again, to make it easier to calculate. So let's see how that all fits together. So now we know the specs of the LED. We know that it requires a 2-volt drop, and the current we're going for is 20 milliamps. If we put more, if we allow it to draw, it will draw more if we let it. So if we allow it to draw more than 20 milliamps, it will burn itself out. So I've switched over to a little spreadsheet here, and I've dictated here red LED, the voltage drop, or otherwise known as forward voltage. Let's say it's 2 volts on that LED, and that varies depending on the LED you have, but let's just go with 2 volts. And the current that LED requires for a nice bright light is 20 milliamps. Again, depending on, you should check the spec sheet of your own LED, but let's use those numbers and work with that. Okay, we know that our LED takes up 2 volts. So if we go back to our drawing, I've added a little notation here. Our LED takes up 2 volts. Let me run our simulation again here. If we've got a 9-volt supply, and if the LED takes up 2 volts, there's 7 volts left over that we have to pick a resistor appropriately for that 7 volts in order to calculate current. So let's go back to Ohm's law and see what that all means. We know that the LED takes 20 milliamps, and we know that it takes 2 volts. It uses up 2 volts. So we've got 7 volts left. We got to figure out what we need to put in here to use up that 7 volts. So again, we're going to use Ohm's law in order to calculate that resistance. We're going to divide the voltage, which is 7, by the current, which is 20 milliamps or 0.02. So let's go over to our spreadsheet. Checking our formula here, R equals E over I. So R equals E divided by I. And let's take that a step further then. R equals, we decided we have to use up 7 more volts because the LED uses up 2 of those volts. So 7 divided by the current, which is 0.02 or 20 milliamps. So let's take that one step further. Now we have to actually do that calculation. If we do that in Excel, we can just leave R here, and we can go over here and we can say equals 7 divided by 0.02 and hit enter. So we know R equals 350. It's kind of a messy looking formula there. Let's try it in our calculator. It might be a little easier. So the formula that we are after is R equals E over I. R equals 7 divided by 0.02. So let's go 7 divided by 0.02 equals 350. 350 here, 350 here. It doesn't matter how you get it, but you get it. So let's go back over to our little drawing here. And we're after 20 milliamps. Right now I plugged in a resistor that's giving us 15 milliamps. I plugged in a resistor of 450 ohms. But our calculator tells us we need 350. So instead of 450, let me change that to 350. And voila, we have 19.8 milliamps. So Ohm's law did us true. If we put a resistor in there of 350 ohms, we are going to limit that current to 20 milliamps. Isn't life wonderful when things work out? Just for kicks, let's say that 20 milliamps is too bright. Let's say that we want to knock that down to 10 milliamps. What would we do? Easy enough to say, well, we just have to double that resistance to have the current. It's easy for me to say because I'm used to doing this sort of thing. Let's use Ohm's law to figure out what we need to do. And you need a little bit of background, perhaps, knowing that if we want that to be half as bright, we only have to allow half the current. So that may not be forthcoming to you, but hopefully if you're playing around with this stuff, that will be something that makes sense to you at some point. But I guess you can just trust me and say we need half the current to make it half as bright. So if we need half the current, what size resistor? Well, we can figure that out. Well, no, if you don't have the history, you don't know that if you double the resistor, you'll have the current. But we can go learn that through Ohm's law. So let's go back over to our chart. If we want that brilliance to be half as much, I guess you're just going to have to know that you want half the current. So now, using Ohm's law, we want to do 7 volts divided by 0.01. Let's go to the calculator. It might be a little easier to do that. Let's do 7 volts divided by 0.01. See what that equals. 700, exactly twice the value of that resistor. So what I was telling you, it sounds like it was true. Let's go back to the drawing. If we want to have the current, we need to double the resistor. So right now, we've got, let's click on it to find out again, we got 350 ohms. Let's change that. We're going to double that to 700 ohms. And voila, we've got 10 milliamps. And the LED is half as bright as it was a minute ago. All right, go ahead and watch the LED. I'm going to change this back to 350 ohms and you can watch the LED get brighter. But keep an eye on that little beauty. And notice now I have 0 resistance for that resistor and the LED blew up. So that's actually a good lesson. If you have too little resistance, you'll fry that LED. And so that's a good lesson. Let's take a look at that lesson. Let's change that. If that resistor is too low, if we exceed the limits of the LED and change that to, oh, I don't know, 0 was horrible. Let's change it to 100 ohms and see what happens. Notice we just got a little warning sign here from the program. Current through the LED is 65 milliamps, while recommended maximum is 20 milliamps. The usable lifetime of the LED may be reduced. Yeah, to like nothing. It'll blow if you put 66 milliamps through there. So 100 ohm resistor is too small. So you got to be careful about that unless you got lots of LEDs on hand that you can afford to blow them up. So we decided that 700 milliamps was about half brilliance. or 700 ohms, half brilliance at 10 milliamps. 350 ohms was full brilliance at 20 milliamps, assuming that our voltage always stays at 9 volts. Want to have some more fun? Let's say we only have a 5-volt supply. Let's see how many people drop off this video at this point, and let's see how many of you get extra credit. If we're going to limit 10 milliamps through that LED, but our supply changes to 5 volts, what are we going to need for a resistor? Let's go back to 20 milliamps, seeing as we already have worked on that a little bit. Let's go back to 350 ohm resistor, 20 milliamps. If we want to keep it at 20 milliamps, but we want to change our supply to 5 volts, what size resistor do we need to use? And so you can go to Ohm's Law and you can do some calculation, or if you're using this slick software, you can just change it in here and you can fry the pretend LED with no worries. You don't have to blow up your own supply of LEDs, not your own power supply, although you want to be careful of that too, I guess. So let's say, okay, we're just going to change that voltage to 5 volts. So let's click on here, and we can actually dial it down on a little dial here, or we can type it in over here or up here. Let's change it to 5 volts and hit enter. All right, now we got 8 milliamps. Let's think about that for a minute. We about halved the voltage supply from 9 to 5 is roughly half. So we can assume it's a direct relation. You don't assume this, you know it through Ohm's law. It's a direct relationship. Voltage is directly related to current. And if you're any good at algebra, you can see that in the formula. Voltage is directly related to current, but without getting into that heavy algebra stuff that blows my mind and may blow your mind, let's go back to the simple software. You can just know, maybe you can just tuck this away in your head somewhere. Voltage is directly proportionate to current. So if you have the voltage, you're going to have the current. And so you can play around. This is just a wonderful tool to play around with that stuff. If you only have 5 volts, what's the current going to be when the resistor is 350 ohms? Well, what's the current going to be if we put that 700 ohm resistor back in there? If you think about that a little bit, this is all direct proportionate stuff. If we double the resistor, what's going to happen to the brilliance of that lamp? What's going to happen to the current? If we double the resistance, all that flow business is going to halve. So this is going to get dimmer, and our current is going to go roughly half of that, so down to 4 milliamps or so. So let's type in 700 ohms here, and sure enough, 4.4 milliamps, and the LED is much dimmer. So this is a tremendous tool for playing around with that stuff. If you're a glutton for punishment, and if you prefer, you can go figure it out through Ohm's Law and the Ohm's Law chart, which is a wonderful thing once you get going on all this stuff. So take your pick. Do the math if you're a math whiz, or just play around with this software. Even playing around with this software, even if you are a math whiz, makes it really easy to do stuff. And you know, you can go over here and you can pick stuff. If you go over here, say, okay, I want to add a resistor, you can type in resistor here, and you only have to type part of it, and you say, okay, I want to add a resistor. It gives you all sorts of resistance things. If you want a power supply, you type power supply, and then you can drag this stuff over and you can add these to your circuitry. It's just a wonderful little tool for putzing around. I highly recommend it. Okay, there's what I thought was going to be a short tutorial on figuring the resistance for an LED and a 9-volt power supply. I apologize for the length of this, and hopefully you got something out of it. If you did, I'd appreciate you giving me a like, and if you want to see more videos like what you see here, go ahead and hit that subscribe button and click that bell and choose that top choice, or I forget what it is, but it shows that you want to get all videos that I put up. You'll get a notification for all videos that I place. See you on the next video.